we could, it is possible, it would not be a good idea, we could, because this is a multiplication problem, multiply the numerators. We would have to use distributive property there. Multiply the denominators. That would require a lot of box method or distributive property there. And we would have some really ridiculous looking final answer that would still need to be reduced, which means we would have to take whatever weird thing we came up with at the end and try to find some way of factoring everything. Now, it's very difficult to factor polynomials that have exponents beyond x squared. It's a much longer process that would take a very long time for us to complete. So instead, we're going to factor everything here at the beginning, just like we should be doing in a regular fraction problem. So there are 4 different things we have to look at to try to factor, which is twice as many as we had in the simplifying problems. First of all, x plus 5. And we're going to go through the same set of questions every time. The first question should always be, do they have anything in common that I can take out? X and 5. No, nothing to take out. Does it have x squared? Is this something that I can use x method with? I don't see an x squared either. So this can't be factored. We're going to leave it alone. It just says x plus 5. Okay, let's do the denominator. I have 7x minus 21. Starting again, do they have anything in common? Yeah, they're both multiples of 7. Let's take that out. That'll leave me with x minus 3. Now look at what you have inside the parentheses. Does it have x squared? Nope, no x squared, so we don't need to do x method. We're done factoring that, so let's move on to the other one. The numerator here, 14x, it's not a polynomial. It's just a monomial, 14x, which means that you can't do anything with it, you just leave it alone. The only time we could factor something is if there's a plus sign or a minus sign anyway. Now, the denominator, again, and it's very tempting to just jump straight into factoring with x method. You should always start by asking, do they have anything in common? In this case, no. It does have x squared, so we have to do x method here. I want to multiply to make negative 10, but I want to add to make positive 3. Someone raise your hand if you know the numbers that I'm going to need for this. Brian? 5 and negative 2 should do it. So that means that I'm going to get here x plus 5 and x minus 2. Now that's step 1. We factored everything. And what this allows us to do is it allows us to see things that we could possibly cancel out. So we're looking for common factors. So at this point, one of them is really obvious. Can someone tell me what are we definitely going to cross out that should be the really obvious one here? Nicole? X plus 5, definitely. So x plus 5 matches x plus 5. It has to be something on the top and the bottom. So those match, those cancel each other. We're good there, they're gone. There is one more thing that can be done. And it's not something that matches exactly, but it is something that we can still do some canceling with here. Bella? Right, 7 goes into 14. Now some people get very confused here and they're not sure. They say, but the 14 is attached to the x. You can't just take the 14 and not the x. What you have to remember here is that this is 14 times x. It's a multiplication, which means that you can take the two pieces as separate factors. So I can say that 14 and 7 are going to reduce. 7 goes into 14 twice. So the 14 will become a 2. So now looking at all the things we have left, along the top I would now try to multiply things together. But along the top all I have is 2x. On the bottom I have two binomials. I have x minus 3 and x minus 2. You're going to see the final answer written in two different ways. In some cases, some textbooks, some tests, some websites, if you're looking at videos and stuff, they will stop here and say this is our final answer. Now that's acceptable, but I don't think it makes a lot of sense because this is a multiplication problem, which means that we should probably at some point multiply something. So we do have to actually go a little bit further, and I'm going to ask you to go a little bit further with this. And you're going to see it this way at the end of the chapter when we get to the test, and we're going to be working with this along the way. We are not yet done. This is a multiplication problem. There was nothing to multiply on the top, it was just 2x. But on the bottom, I have x minus 3 times x minus 2. Who remembers how I multiply those types of things together? We did a whole lot of this right before winter break, right, Janae? You could use the distributive property. What else? There were actually 3 options, so I want to get all of them. We have distributive property, Savannah. Box method, that was a real popular one. There was one more, it wasn't very popular. Jaime? FOIL method. So distributive property, FOIL, box method, does not matter which one you do. We need to multiply these things together. Now, the most popular one was box method, so I'm going to go ahead and set it up for that. This is 2 terms and 2 terms. So 2 by 2, we have x and minus 3, x and minus 2. X times x was x squared. Negative 3 times x, negative 2 times x, and positive 6. In case you've forgotten, when we do when we do box method, the diagonals are our like terms. We're going to add those together. So our new denominator is x squared from that corner. Negative 3 plus negative 2 would give me negative 5x, and then a positive 6 at the end. So this is the final answer I'm going to ask for you to achieve. Our textbook stops here, so when you're checking final answers in a homework assignment, unfortunately they stop here, so you will want to check your second to last step in your work, and then this will be the final answer that I'm going to expect you to actually have.